How much current the clutch draws is completely dependent on the voltage powering the clutch and the DC resistance of its winding. The resistance across the clutch winding is unique to each clutch, but typically falls within the range of 2 to 4 ohms. If the resistance is too low, the clutch coil will draw excessive current, potentially leading to blown fuses and the destruction of the clutch. This video slide illustrates how the current can be impacted by a lower resistance according to Ohm's law. The power supply for both clutch examples is 13.5 volts direct current. On the left is a clutch with a good clutch winding, measuring 3.3 ohms of resistance and drawing only 4.09 amps of current. On the right is a clutch example with a bad winding, measuring 0.5 ohms of resistance and drawing a whopping 27 amps of current. Using a multimeter, measure the DC resistance across the clutch coil. Set the device to measure ohms. For those with a manual range multimeter, ensure that the range is adjusted to the lowest setting above milliohms. Plug the black test lead into the common port of the multimeter and the red test lead into the port for measuring ohms and volts. Connect one test lead to each of the clutch wires to measure the DC resistance of the coil. If the winding resistance is below 2 ohms or extremely high, you likely have a bad clutch, which needs to be replaced. If your clutch winding is within spec but you're still experiencing blown fuses, the issue likely lies within the equipment harness. It may be necessary to thoroughly inspect the entire equipment harness with the guidance of the equipment manufacturer to accurately locate and address the problem.